Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 5 on trigonometry. It says in the diagram, PR is perpendicular to TS in obtuse triangle PTS, and then PT is equals to root 5, TR is equals to 2. So basically what is filled in the diagram here. Then 5.1.1 says write down the value of A sine T, and then that is only for 1 mark. So what we are just supposed to do here is just go sine T. Here we know that sine, according to Katoa, we know that sine is opposite over hypotenuse. So this is my opposite side and then my hypotenuse. So that means sine angle T is 1 over root 5. And then here cos S, that means I come here. And then cos is adjacent of our hypotenuse. So this is 3 over the hypotenuse is root 10. So that's all you needed to do for those. Then now 5.1.2 says calculate without using a calculator the value of cos t plus s, right? So what we ought to do here for 5.1.2 is just simply write this cos angle t plus angle s. And then now we can say that this is a compound angle for cos, which just goes cos angle of t and then cos angle of s. Now we know with the compound angle for cos, the sign changes, and then this becomes sine t and then sine s. Remember, this is given in your formula sheet. All you just have to do is represent based on the given variables there. Now, what is cos t? We can just come here and say this is adjacent of a hypotenuse. So this will be 2 over root 5. And then cos s, we can see that we already have it there. So that's 3 over root 10. And then now we have sine t already calculated. So it's 1 over root 5. And then now for sine s, this will be opposite over hypotenuse. That gives us 1 over root 10. Right. Now multiplying here 2 times 3, that gives us 6, and multiplying root 5 and root 10, that should give us root 50. Right. So we know the law of suds that goes if I have root A times root of B, this can be written as root A times B. Right. So this is basically what we did here, 5 times 10, and then still inside the square root. Then 1 times 1, it's 1. And then also again, we have root 50. Now we can see that both these terms are expressed with the same denominator. So that means we can just subtract the numerators there. We have 5 and then over root 50. Now note that the root 50 here can be written like this, as 25 multiplied by 2, right? And then this will give us root of 25 is 5, but then root of 2 is just root 2. So this will then be 5 over 5 root 2. Now we can see that 5 and 5 will just divide out there. So we are left with 1 over root 2, right? Now, there is no need for you to rationalize the denominator here. You can just leave your answer like that. And then you have your 5 marks as easy as that. Okay, so let's proceed to 5.2. It says determine the value of 1 over cos 360 degrees minus theta multiplied by sine 90 degree minus theta, and then that. So let's write what we have there. So okay, if we are to solve this, we know that cos, this is represents the fourth quadrant. How is cos in the fourth quadrant? We say it is positive. And then how is sine in the first quadrant? But then note that this represents a cofunction. So our sine here needs to change to cos, right? And then we know that sine in the first quadrant is positive. Therefore, its cofunction would also be positive. Now here we have tan in the third quadrant. It is positive. So this will come out as tan squared theta. Note that when we have the square here, even if the tan was negative in that particular quadrant, it will still come out as positive because now it will be that negative multiplied by negative. So hopefully if I get a question like that, I'll stress that further. Okay, so we have 1 over cos squared theta. And then here, this one, we can break it down to sine squared theta over cos squared theta, right? So do not be confused, guys. I'm solving for 5.2. And then this will give me, again, here we can see a similar situation. We have the same denominator. So that means up here we can say 1 minus sine squared theta over cos squared theta. Now, if you can see this and remember from your grade 11, you had this trig identity here, like this. And then now you knew that if you wanted to make cos squared theta the subject of the formula, it went as 1 minus sine squared theta, which is exactly what we have here. So we can change this to its trig identity, which is cos squared theta. But look now what we have. We now have cos squared theta divided by cos squared theta, which will just give us 1, right? And that's how you were supposed to solve that question right there. Now, okay, let's tackle 5.3. So for 5.3, we are given sine x minus cos x is equals to 3 over 4, right? And then now they say calculate the value of sine 2x without using a calculator, right? So now we know that this is a double angle and it breaks down to 2 sine x cos x according to your grade 12 double angles, right? So what is one creative way in which we can have this from the equation that we are given here? Now, if we are to try to square both sides here, like this will end up being sine x minus cos x. And then since we are expanding, this again will be sine x cos x. But then here we have 3 squared, that's 9, and then 4 squared, that's 16, right? Now, if we have to multiply here, we will end up with sine squared x. And then if we say sine x times negative cos x, that's a negative sine x cos x. And then again, if we say negative cos x times sine x, this is negative sine x cos x. Now, can you see this? Having to add these ones because they have the same sign, it will be negative 2 sine x cos x as your middle term. And then here I have negative cos x multiplied by negative cos x. This is positive cos squared x, and then is equals to 9 over 16. But then if I can just write it like this, sine squared x plus cos squared x, you can now see that this is coming from your grade 11 trig identity, which we know this is equivalent to 1. But look at this now, 2 sine x cos x, it is equivalent to the grade 12 trig identity of the double angle. Then is equals to 9 over 16. Now let's change this. This is equals to 1. And then here we will have the sine 2x equal to 9 over 16. At this point, what we can do is bring over the 9 over 16 to the left-hand side and then take this to the right-hand side. This is sine 2x. And then at this point, you can just press your calculator to find your value. It's not like they would notice that. But if you still want to flex your maths muscles, you can just go 1 can be expressed as 16 over 16 and then 9 over 16. Then this is equals to sine 2x. Now at this point, you can say what is 16 minus 9? That's 7. So you have sine 2x is equals to 7 over 16. So that represents the numerical value for sine 2x. And that's how you are supposed to do it, guys. Please press the thumbs up button if you have enjoyed the lesson. And then if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.